Okay, so these are the solutions for topics 2 and 3, test review part 5. For this one, I'm just going to go ahead and actually do the assignment. Okay, so it's just one question. It's just a long matching question. So my first word is adjacent angles. So that would be this first picture. They're adjacent because they share the vertex O and the ray OB. Okay, the next one is angle bisector. So let's scroll down here looking for an angle bisector. Okay, so this image right here, it shows an angle in blue, like a large angle, and then it shows a red line that cuts right through the middle. That red line is the angle bisector of the blue angle. And it even shows those two little arcs saying that they're the same. So that's what angle bisectors do. They go right through the middle, creating two smaller half angles. Okay, so my next word is vertical angles. Vertical angles. That's this image. That's the fact that when you have two lines intersect, making an X kind of shape, the opposite angles are congruent to each other. Okay, my next word is transversal. So I'm pretty sure that's this one near the bottom. Let me just make sure there's nothing else. Okay, yeah, it's this one. So the transversal is the non-parallel line there. It's the one that intersects both the parallel lines. Okay, my next word is hypotenuse. So hypotenuse is the third side of a right triangle. Okay, so it's this image right here. It's kind of a messed up picture because it doesn't really say it's a right triangle, but that's the one. Equilateral triangle. So an equilateral triangle is a triangle for which all the sides are the same. Okay, so this image right here has the 3 marks for each of the sides. Sorry, each side has 1 mark, so they're all congruent to each other. Equiangular triangle. Turns out that those are equivalent to equilateral triangles. But more specifically, it means that all 3 angles are the same. So that would be that picture at the bottom, which is explicitly saying that A equals B equals C equals 60. Okay, so that's that one. Congruent triangles. So 2 triangles are congruent when all their parts are congruent. So that would be this one, that black one in the middle. So let's see if I can manage to bring this down here. Okay. Side, side, side congruence. That's the fact that when you know that the 3 sides of a triangle are congruent, then that implies that all 6 parts of the 2 triangles are congruent. So that would be this colorful picture here. I think if I just hold it, it'll scroll down or something. Nope. How do I get this down here? Can I move this down? Nope. Okay. So I think for the rest of these, I'm just going to have to point them out to you. So side, side, side congruence is this this colorful one with the triangles ABC and triangles PQR, the one that I'm currently trying to move around right now. That's side, side, side congruence. Okay, side angle side is when an angle and its 2 sides So that would be the last picture there. See that angle 30 and its two sides are congruent in both of the triangles. That's called side angle side congruence. And basically, if you just know those three parts are congruent between the two triangles, then that means that the rest of the 6 parts are congruent between the two triangles. Okay. Angle side angle. That would be the second picture there with triangles ABC and EFD. The two angles that are congruent, the two pairs of angles are 51 and 51 and 45 and 45 being congruent, and then the side with length 7 being congruent. That's angle side angle. Okay, and then angle side congruence. That is the picture at the very top. Triangles ABC and PQR. The two pairs of angles that are congruent are the two 40-degree angles and the two 80-degree angles, and then that one off side to the right. So that's angle side congruence. And the way that we would say that with the definition was it's two angles and an unshared side, as opposed to angle side angle, which was two angles and their shared side. Okay, so angle side is the very top picture there. Okay, and then hypotenuse leg. That's the shortcut for that one, that picture at the bottom there with the two black right triangles. So that shortcut just basically said if you have two right triangles and you know their hypotenuses and their legs are the same, then that implies that the totality of the two triangles are the same. Actually, this one doesn't show that the hypotenuses are the same. Like, there's no marking. But it was the only one left. Okay. So that's it for that.